All right, continuing on now with our study of functions. This whole unit is about functions, domain, range, different things that you can do with functions. One of the most popular functions, or one of the most common functions, are linear functions. Linear equations are things that you've seen since probably 6th, 7th grade, 8th grade, Algebra 1, right? You've seen them just about every year. And so it's things that you should be familiar with. A lot of things that we see today you should be very familiar with, like slope, intercept, and things of that nature. We're starting off with equations, linear equations in standard form. And standard form is what I have circled here in blue. Ax plus by equals c. What's going to happen is, at the end of the day, you're still going to have an x and you're still going to have a y in that equation. You could have something that looks like 2x plus 3y equals 6, right? That's an example of an equation in standard form. You have ax plus by equals c. The x and the y are still in the equation. The a, the b, the c are all just numbers. They don't mean really anything for the formula. Or for the equation. You're going to hear me say formula a lot, and what I mean is for this specific equation, or for this form of the equation. Each form of an equation has its own benefits and has its own drawbacks. One of the benefits of standard form is that it makes it really easy to find x and y intercepts of your equation. And so to find an x-intercept of an equation, to find an x-intercept, you sub a 0 in for y, and to find a y-intercept, you sub a 0 in for x. You're always subbing in a 0 for the opposite form. So in this equation, for example, if I wanted to find the x and y-intercept, what I would do is I would first start by saying, here, we'll color code this. We'll find the x-intercept. 2x plus 3 times 0. Sub a 0 in for y. The 3 times 0 eliminates itself. That's just 0. Then we can divide both sides by 2, and x equals 3, right? So then my x-intercept as a point is 3, 0. We subbed a 0 in for y and got out 3 for x. We'll color code this one in purple. The y-intercept, we need to sub a 0 in for x. 2 times 0 plus 3y equals 6. That 2 times 0 will eliminate itself. That's just 0. 3y equals 6. Divide both sides by 3, and y equals 2. So we subbed a 0 in for x and got a 2 out for y. That is, again, the benefit of this form of the equation. It makes it really easy to find your x and your y-intercepts. With those x and y-intercepts, we can graph. It just gives us some information about the equation, right? The first thing we're starting with, oh, look at this serendipity. We did not know that this was going to be our first equation. But we just, with any graph, one way that you can graph them, or with any equation, one way you can graph them is with a t-chart. As long as you can find 2 good points on that graph, then you can graph that equation, right? And so we just subbed in a 0 for x and got a 2 out for y. We subbed a 0 in for y and we got a 3 out for x. We can plot those 2 points just like we were doing in the first lesson of this unit. So over 3, 0 should be about right there. 0, 2 is right there. And now we can draw a line through those 2 points. For any of these equations, if we can find any 2 points, then we can draw a line through them. The easiest way to find 2 points, in my opinion, is to do a t-chart, and you could plug in any numbers. You don't have to use 0. I could plug in a 1, a 5, a 7. It doesn't matter, a -7, right? I'm just plugging in numbers that are convenient for me, numbers that I think are going to work well in the equation, and typically I'm always starting off with a 0 for the x and a 0 for the y and seeing where that gets me. If it doesn't get me good numbers, then I'll try something else. We'll color code this next equation in yellow. Anytime, so I said on the last slide, typically you have an x and a y still left, right? But that's not necessarily true. Sometimes you only have an x, sometimes you only have a y. If you ever just have an x, then you know that that's always going to be a vertical line. Vertical. If it only has an x, it's going to be a vertical line. If we wanted to do a t-chart for that, we still could. And we could pick any number for y that we wanted to. -1, 5, 7, 10, 1, 3. Doesn't matter what it is. X is always -3. That's what the equation tells us, is that x is -3, right? And what that tells us is that on our equation, -3, 0, x is -3, x is -3. If I plot any or all of those points that I have on this t-chart, I'm always going to get something that's on that vertical line right there. In the same way, or conversely, with the equation that only has y's, if I divide both sides by 2 here to simplify this a little bit, if I have an equation that only has y's in numbers and no x's, that's always going to be a horizontal. Come on now, horizontal. And we can extrapolate from that prior, but I'm going to go on and do a t-chart here. So x and y, I can put any value in I want for x. And y is always going to be 2. That's what my equation tells me, is that y is equal to 2. So if I go and start to plot some of those points that I have in that t-chart, notice that they all lie directly on that horizontal line. So you know that any y equals line is always going to be horizontal. Any x equals line is always going to be vertical. If it's just x equals a number, it's vertical. Y equals a number, it's horizontal. If we want to find the slope, if we have 2 points, say, like we had up here, we have these 2 points, right, in blue. If we want to find the slope between those 2 points, we can apply this formula right here. This is a formula that everybody's familiar with. y2 minus y1 over x2 minus x1, where every point is an xy coordinate. As long as we have 2 points, we can use that formula to find the slope. People call it change in y over change in x, but more commonly people call it rise over run. So when we get ready to graph, it's really easy to talk about rise over run to say, how are we going to get this next point? Well, we're going to use the slope and do rise over run. Let's see an example of this. If we want to find the slope, I have this highlighted because I'm just going to apply the formula, right? I know that slope is y2 minus y1 over x2 minus x1. I've already labeled my points here, x1, y1, x2, y2. And then when I sub in the values, y2 minus y1 over x2 minus x1, we can simplify. A negative over a negative is going to make a positive, and that's our slope. The same thing on the bottom, even with fractions. As long as you're good with a calculator or good with fractions, you should be great at this. You're just going to sub in the numbers, simplify in the calculator, and there's your slope. If you have a horizontal or a vertical line, the same still applies, right? We know for a fact that for a horizontal line, the slope is going to be 0. But if we still wanted to check it with those 2 points, I'm just looking at these 2 points that I have dotted here, right? So that's 2, 3, and 4, 3. If I sub those into that slope formula, you still end up getting a slope of 0. You see that? And exactly the same for a vertical line. If I pick any 2 points on that vertical line, 2, 1, and 2, 3, and sub them into the slope formula, I get 2 over 0, which is undefined. And the calculator, it'll give you something like a domain error. We can generalize slopes by talking about just like how fast is a man moving, right? If he's walking from left to right, is he moving up? Is he moving down? Is he moving perfectly horizontal or vertical? If we're talking, I like to generalize and use this analogy that if a man is walking left to right up a mountain, right? If he's walking up that mountain, that's a positive slope. If he's walking down that mountain, that's a negative slope. If he hits a flat spot, that's a 0 slope. And if he hits a sheer wall that he cannot climb, right, that would be an undefined slope. There's a summary of that on this next page. We don't have to dwell on this page. It's the same thing I was basically just saying. If you're rising from left to right, it's positive. If you're dropping from left to right, it's negative. If there's no change left to right, it's a 0 slope. And if you cannot pass the barrier left to right, it's an undefined slope. The next form of a line is the slope-intercept form. This is one that you're probably most familiar with. That's y equals mx plus b. And just like with standard form, the x and the y are going to remain in the equation. The x and the y are going to remain in the equation. The m and the b are going to be just numbers, right? Where m, I have labeled down here, is the slope, and b is the y-intercept. 0 comma b is the point that the y-intercept lies on. This one, again, I said every form has its own perks, right? And it has its own downfalls. The perk of this one is that you can see the slope, you can see the y-intercept within the formula. All I have to do is go and plot that y-intercept, use the slope to find my next point. It's a little bit harder with this form to find both the x and the y-intercept, right? Let's see some examples of this. Use the slope and the y-intercept to graph. So I have the standard form of an equation, right? If I want to get the slope-intercept form from this standard form of the equation, all I'm going to do is, you notice that in slope-intercept form, the y is by itself. Once you get the y by itself, you pretty much are going to have it in slope-intercept form, y equals mx plus b. So I'm starting with my general equation. To get y by itself, I can subtract 3x from both sides. That leaves me with this. To get y by itself, I can divide by 4 on both sides, and that leaves me with y equals mx plus b. If we want to determine the slope and the y-intercept, the slope is just the m portion of that. The b is the y-intercept portion. We said that slope is the same thing as rise over run. That's going to help us when we get ready to graph. And so on our graph, you're always going to start with the y-intercept, 0, 1. And then to find your next point, you're going to use the slope. So the slope is negative 3 over 4. I need to go down 1, 2, 3 over 1, 2, 3, 4. I'm going down 3 over 4 from that point that I already graphed. I'm not going from the origin. I'm going from the point that we already have. And then I can draw my line through those 2 points. Notice that these equations are equivalent. This one right here, that form of my equation, is the same as this one right here. They don't look the same, but it is the same line, right? They're just written in 2 different forms. All right, we're moving on. We're sort of climbing the ladder here and making things a little more difficult and a little more difficult. This one says write the equation of a line that passes through the point. Passes through the point. It gives us a point, and it gives us a slope. In a minute, we're going to get another form of the line called point slope. Right now, we don't have that. So here's what we can do. We do have y equals mx plus b. We do have ax plus by equals c. We have to sort of determine there what information do we have and what do we not have. We have a slope. This is slope-intercept, so maybe we should use the slope-intercept form. We could sub the negative 4 in here. We could sub in this x, y to x and y. And then we could solve for b. And now that we have b, the y-intercept, we can go back and use this form again. We already know what m is to write it in y equals mx plus b form. If we wanted it in standard form, then all we would have to do is move those numbers around, right? We would just move those numbers around to get it to look like that. If we wanted it in standard form, we would just add the 4x to both sides, and we would have 4x plus y equals 5. All right, so now we have both forms. It didn't say specifically which form that it wanted, so we have a copy of both. We have standard, and we have slope-intercept. This is a function. You can always replace y with f of x. This is just function notation. It says write the linear equation using function notation where f of x equals y. All that's saying is replace the y with f of x. Function notation, any f of x is the same thing as a y. All right, now on to some applications of linear equations. Again, I always say this, math doesn't live in a vacuum. It's not in its own bubble. We're not doing math just to do math. We want to actually apply it to something at the end of the day. We can apply the point slope formula. All right, finally, our third form of the equation. It's right here, y minus y1 equals mx minus x1, and I've added it to our chart. This chart is something that you should write down, take to heart, memorize what each form of those equations look like. Our example 1 says we're going to use point slope form to find the equation of the line passing through. Look what we have here, a point and a slope. How handy. So if we have a point and a slope, we're pretty much always going to start off with point slope form. Again, the y and the x are going to remain. Everything else is going to become a number. We have a x1, a y1, and an m. So a slope and a point. Just like the form says, it's slope point. This is our x1, that's our y1, and that's our m. So writing in a point slope form would be something like y minus negative 3 equals negative 4 x minus 2. That's the same thing as y plus 3 equals negative 4x plus 8. We want this in slope-intercept form, so y equals mx plus b is what we want it to look like. We almost have it there. If we subtract the 3, we'd have y equals negative 4x plus 5, which is y equals mx plus b. That is our slope-intercept form. This is a learning point right here where we said that everything has its key, like there's a balance, right? Everything has its pros and cons. The con of this is that it just doesn't look nice, right? Point slope form just doesn't look nice. But the pro is, most of the times what you're going to be given is some form of the slope or some information about the slope and a point. And if you're given that information, you're almost going to always go to this, right? You can work your way around in slope-intercept or with standard form, but with a point and with some information about the slope, it's easier to just go straight to point slope form. Here's an example. Write an equation given 2 points. We want our final answer in slope-intercept form. So we have 2 points, right? We have a x1, a y1. We have a x2, a y2. Our 3 equations are slope-intercept, point slope, and standard. We don't have a point point. There's no point point. And so what we need to do is we have some points. If we could find the slope, then we could start with point slope form. We have 2 points, so we can find the slope, right? We have a slope formula that involves 2 points. Sub it in the values that we have from our point. We end up with a slope of -8/5. Now that we have a slope and we have 2 points, we can pick either of those points. I'm just going to go with the first one here. We can go to our point slope form. Sub in x1, y1, and m. Try and simplify a little bit. That's not a 2 there, that's a question mark, and we've already solved for m right over here. Again, we can distribute the -8/5 in, subtract the 6 from both sides, and then try and get y by itself to get slope-intercept form. Y equals mx plus b. If it gives us information like a point and information about being parallel to a line, right? We still have a point and we still have information about the slope, right? We don't have a slope, but we have information about the slope. What we want to know is, what is the slope? If it's parallel, so here's a note to make. If you have lines that are parallel, their slopes are the exact same. We're going to see in a minute an example that relies on perpendicular lines. If you have lines that are perpendicular, they're the opposite reciprocal, and we'll talk about that on the next slide. So for now, we need to know that parallel lines have the same slope. So what is the slope? What do we need to know? What is the slope? In yellow here I have boxed, what is the slope of this line right here? What is the slope? If we can get that into y equals mx plus b form, then we can find the slope, right? There's our original equation. We can subtract x from both sides. We can divide by 4 on both sides. And now we have y equals mx plus b, and so we know our slope is -1/4. If our line is parallel, then it has the same slope, right? Now that we have a slope, and it's given us a point, then we can go to point slope form. Sub in the information that we know, that's x1, that's y1, and there's our m. And we want to eventually get it into slope-intercept form. So we want to get y by itself. Simplifying, we can add the 1 to both sides. It says we also want to get it into standard form, which is ax plus by equals c. So if we want it in, we want to eventually get it also into ax plus by equals c. That just means the x is first, the y is second, the c is last, the number's on the other side. We also don't really want fractions with standard form. So let's get the x over to the other side. We can multiply by 4 to get rid of the fraction. And then we end up with this. That's ax plus by equals c. Our c just happens to be 0, right? That's our standard form. That was a lot of work for one problem, but we're seeing 3 forms of the same line, right? We have point slope form, we have slope intercept form, and we have standard form. All 3 the same exact line, just different ways to write that line. All right, a second ago I said that we were going to talk about perpendicular slopes. This says it's perpendicular to the line defined by this, right? So then again, what is the slope? What in the world is the slope? For any slope, if I have 5/7, to find a perpendicular slope, I'm going to flip the fraction and change the sign. So instead of positive, I'm going to make it negative, and I'm going to flip the fraction. If I have a whole number, like if I had a -3, for example, that's the same thing as -3/1. If I want a perpendicular slope, that would be +1/3. You're always going to flip the fraction and change the sign, positive or negative. So if ours is perpendicular to this line, the slope of this line, this is mx plus b, the slope of this line is 1/2. So then our new slope is going to be -2, right? We're going to take that fraction, flip it, and change it to a negative. Now we have a slope, and we have a point, x1, y1. We can go to our point slope form. We can try and simplify on the right, subtract the 3, and that gives us slope-intercept form. This says we want slope-intercept and standard form. Remember, standard form is your ax plus by equals c. So to find standard form, all we need to do is add our 2x over. And there's our standard form. Again, we have three versions of the same exact line. We have point slope, slope intercept, and standard. All three the same line. All right, this is our final slide here. A family cell phone plan costed $130 per month for 4 lines. Every additional line costs $19.99 per month. We're getting the first 4 lines for $130. After that, you're going to pay $19.99 per month. We want to write a linear function to model the cost of a family plan for every member added beyond the first 4. So we know we're paying $130 flat, right? We're paying $130 regardless. For the first 4 people, we're paying $100. Now after that, if I pay for a 5th person, that's $19.99. A 6th person is another $19.99. A 7th person is another $19.99. It's $19.99 for every single person. That's our variable cost, right? Being a variable cost, that's the number that's going to go with our variable. So our cost function should look something like this. A fixed number 130 is not going to change. And then $19.99 for every person, right? $19.99 per person after that. This says evaluate C of 3. Remember, to evaluate C of 3 for C of x, we're just going to sub in a 3 for x. So C of 3 would be 130 plus $19.99 times 3. I'm just going to do some calculated work here and get that being the total cost for 4 plans plus 3 additional plans, right? It's $130 for 4 lines, and then everyone after that is an additional $19.99. So if we're trying to interpret this in the context of the problem, this is 3 more, right? That's 3 more. We've already got 4 people on there. That's $130. For 3 more people, that makes a total of 7 people. It's going to cost $189.97.